Hello and welcome to Module 8, Natural Language Processing, NLP. Natural Language Processing, NLP, is a specialized field within artificial intelligence, AI, that focuses on the interaction between computers and human language. NLP involves developing algorithms that allow computers to understand, interpret, and generate human language in a meaningful way. NLP is used extensively in tasks like language translation, sentiment analysis, chatbots, text summarization, and speech recognition. In this module, we'll dive into the fundamentals of NLP, its key techniques, and real-world applications. We'll also cover how deep learning methods, such as recurrent neural networks, RNNs, and transformers, have significantly advanced NLP over recent years. Key concepts in natural language processing, NLP. 1. Text preprocessing. Text preprocessing is the first step in any NLP task. Raw text data must be cleaned and transformed into a format that machine learning models can process efficiently. Common preprocessing steps include tokenization, the process of splitting a text into smaller units such as words, sentences, or subwords. Tokenization breaks down sentences into tokens that the model can analyze. Stop word removal. Common words such as the, is, and in that do not carry significant meaning and can be removed to improve the efficiency of the model. Stemming and lemmatization. These processes reduce words to their root forms. Stemming cuts off prefixes or suffixes, e.g., running, run, while lemmatization converts a word to its lemma, e.g., better, good. Part of speech, POS, tagging. Assigning a part of speech, such as noun, verb, adjective, to each word in a sentence. This helps identify the roles of words in a sentence. Named entity recognition, NER. Identifying and classifying named entities in text, such as persons, organizations, locations, dates, etc. 2. Bag of words, BAW, and TF-IDF. Before feeding textual data into machine learning models, it's essential to convert the text into numerical vectors. 2 popular methods for doing so are bag of words, BAW. BAW is a simple representation where each word in the text is treated as a separate feature. The text is represented by a frequency count of words in the document. Term frequency inverse document frequency, TF-IDF. TF-IDF is an improvement over BAW that takes into account the importance of words in a document relative to a collection of documents. It reduces the impact of common words such as is, the, etc., and highlights more meaningful terms. 3. Word embeddings. Word embeddings are a more sophisticated method of representing words as vectors in a continuous vector space. Unlike BAW and TF-IDF, word embeddings capture the semantic meaning of words based on their context. Popular techniques for generating word embeddings include Word2Vec. Word2Vec is a neural network model that learns word embeddings by predicting the surrounding words in a sentence, continuous bag of words, or the current word based on the context, skipgram. GLOVE, Global Vectors for Word Representation. GLOVE is an unsupervised learning algorithm that generates word vectors based on co-occurrence statistics from a large corpus of text. Fast text. Fast text, developed by Facebook, is similar to Word2Vec but has the advantage of representing subword information. This is especially helpful when dealing with out-of-vocabulary words. For recurrent neural networks, RNNs, in NLP. Recurrent neural networks, RNNs, are particularly useful in NLP because they can process sequences of data, such as words in a sentence, by maintaining a hidden state that carries information about previous words. RNNs are designed to handle sequential dependencies and are used in tasks like machine translation and sentiment analysis. Bidirectional RNNs. These networks process sequences in both directions, from left to right and right to left, helping the model understand context more effectively. Long short-term memory, LSTM, networks. LSTMs are a special type of RNN that is capable of learning long-term dependencies and preventing the vanishing gradient problem, which can hinder the learning process in traditional RNNs. 5 transformers in NLP. Transformers have become the dominant architecture for NLP tasks due to their ability to handle long-range dependencies more effectively than RNNs. Transformers use self-attention mechanisms to process input data in parallel, which allows them to scale better and handle large data sets. Self-attention. Self-attention allows the model to weigh the importance of each word in a sequence relative to others. For example, in the sentence, "The cat sat on the mat," the model can learn to associate cat with sat and mat with sat through self-attention. BERT, bidirectional encoder representations from transformers. BERT is a pre-trained transformer model developed by Google that understands context in both directions. BERT can be fine-tuned for a wide range of NLP tasks, including sentiment analysis, question answering, and named entity recognition. GPT, Generative Pre-trained Transformer. GPT, the model you're currently interacting with, is based on the transformer architecture and is fine-tuned for language generation tasks. It can be used for text generation, summarization, and other NLP tasks. 6 applications of natural language processing, NLP. NLP has numerous applications in various industries, including sentiment analysis, analyzing customer feedback, social media posts, and product reviews to determine whether the sentiment is positive, negative, or neutral. Machine translation. NLP enables automatic translation between languages, such as Google Translate. Chatbots and virtual assistants. NLP is used in developing conversational agents like Siri, Alexa, and Google Assistant. Text summarization. NLP models can automatically generate summaries of large text documents, which is useful in areas like legal research and news aggregation. Speech recognition, converting spoken language into text, which is the basis for voice assistants, transcription services, and automated customer service systems. Glad you could make it to the end of the module. Take the quiz to continue to the next module.